A Voyager 1. Launched in 1977, it has survived 4 decades in space and is today the only thing we have carried with us into interstellar space. But what exactly is this probe? How is it still functioning? And, most importantly, how much longer will we be able to hear its pulse of life before we lose contact with it forever? Today, we're going to dive into the epic journey of Voyager 1, its original mission, its records, what it's carrying into the cosmos, and, of course, the inevitable end of its communication. Fasten your seatbelts, and let's go. Voyager 1 wasn't built to go to infinity. Its initial goal was much more modest, to take advantage of a rare planetary alignment, the Grand Tour of the gas giants. Voyager 1 wasn't built to go to infinity. Its initial goal was much more modest, to take advantage of a rare planetary alignment, the Grand Tour of the gas giants. Voyager 1 was the first to show us the active volcanoes on Jupiter's moon Io and the thick, hydrocarbon-rich haze surrounding Titan, Saturn's largest moon. After the Saturn encounter, NASA made a crucial decision. It used the planet's gravity to send the probe out of the plane of the solar system, toward the unknown. The original mission ended there. The extended mission, the most important of all, was just beginning. In 1990, at a distance of over 6 billion kilometers, Voyager 1 took one of its most famous photos, the pale blue dot, Earth, seen as a speck of dust suspended in a sunbeam. A poetic moment, requested by Carl Sagan himself, which marked the end of the image collection phase. The next big record came in 1998, when it overtook Pioneer 10 and officially became the most distant human-made object from Earth. Since then, nothing has caught up to it. It's traveling at about 60,000 kilometers per hour and is moving away from the Sun at a speed of over 3 astronomical units per year. But the most important record came in August 2012. After years of measurements, Voyager 1 crossed the heliopause, the protective bubble of particles and magnetic fields created by our Sun. For the first time in history, it entered interstellar space, a landmark that defined our era of exploration. Voyager 1 is more than a scientific probe, it's a time capsule. Attached to its body is a gold-plated copper disk, the Golden Record. Should the spacecraft be found by an alien civilization millions of years from now, this disk is our letter of introduction. The disk contains 115 images, sounds from Earth, such as thunder, wind, and animals, and a selection of music from various cultures and eras, including Bach and Chuck Berry. There are also greetings in 55 languages. It is a sample of life, science, and culture from planet Earth. And in case you're wondering, yes, Earth's location is shown in a diagram on the cover of the record. Voyager 1 is our message in a bottle, launched into the cosmic ocean. She is over 25 billion kilometers from home. There isn't enough sunlight for solar panels. So, how does Voyager 1 keep running and sending data? The answer is radioactive decay. The power comes from its 3 radioisotope thermoelectric generators, RTGs. They use the natural heat released by the decay of plutonium-238 to generate electricity. It's a reliable power source, but one that slowly depletes. But one that slowly runs out. At launch, it was generating about 470 watts of power. Today, that number is well below that. Communication is done through NASA's Deep Space Network, DSN, a global network of giant antennas. The signal, traveling at the speed of light, takes over 23 hours to go from Earth to Voyager, and another 23 hours for the reply to return. It's a conversation that takes almost 2 days. And the main challenge today isn't distance, but power management. The engineering team is in a race against time, switching off instrument by instrument to keep the most critical system, the radio transmitter, operational for as long as possible. The Voyager 1 probe has a limited future in terms of communication. Although the mission is being extended, the amount of electricity generated by its RTGs is the decisive factor. The mission's last gasp will occur when there is no longer enough power for the radio transmitter, with optimistic estimates suggesting communication, possibly only engineering data, until 2036. After communication ends, Voyager 1 will not stop. It will continue its journey in eternal silence towards the star AC +79 3888, which it will reach in approximately 40,000 years. If you're enjoying the content, don't forget to leave a like and subscribe so you don't miss the next videos. Voyager 1 is proof that our curiosity knows no bounds. It's a piece of 70s technology that has survived the test of time and space. And, even in silence, it will be our longest-lived explorer, navigating as a beacon of our civilization. And you? Which Voyager 1 discovery do you find most fascinating? The pale blue dot, the Golden Record, or the entry into interstellar space? Leave your thoughts in the comments below. If you enjoyed the video, don't forget to like and subscribe for more stories from the universe.